Hey, how's it going? Mr. Farrell here. Today in this video, I just wanted to do a brief tutorial on the force equation, F equals ma, Newton's second law of motion. Okay, so this equation is really a simple equation. It is covering how to calculate force, and you calculate force by taking your mass and multiplying it by your acceleration. So very straightforward, three variable equation. We've worked with three variable equations before. I just want to make sure to break this equation down so that, we can, if you are struggling using this equation and your algebra skills aren't as strong right now, you can build up those skills by watching this video and doing some practice problems. So we're going to do a total of 3 practice problems in this video. One of the practice problems we're going to be solving for the force. The other practice problem we'll be solving for the mass, and the last practice problem we'll be solving for acceleration, okay? So let's go ahead and hop into it. As you see, I've got my ICE method written out here, all right? Identify, categorize, equate, evaluate, all right? So we're reading our problem and we're identifying all the numbers and the question. Categorize, we're using those numbers and connecting them with one of the symbols that will help us choose our equation. Equate, we're going to choose what equation we're using, and then and evaluate, we are going to solve the problem, okay? Solid. So for our first problem, it says the mass of a car is 4,000 kilograms. As it falls to the ground, it accelerates at 9.8 meters per second squared. What is the force of the car when it hits the ground? Okay, so with this problem here, again, we are just walking through the problem and writing down every single number that we see, every measurement. So we saw 4,000 kilograms, we saw 9.8 meters per second squared, and we always want to write our question mark. If you do not write your question mark to categorize it, then you won't know what you're looking for. So always remember to write your question mark while you're doing the ICE method, okay? So now we're going to pair these up with different symbols, different variables. All right, so 4,000 kilograms. First of all, in the problem, it tells us that this is the mass of the car. So if you ever get confused as far as what your measurements are and how to categorize them, just read the problem more closely, because the problem tells you what each measurement is. So this says the mass of the car. The other reason we know it's mass is because it has a unit of kilograms. Anything with kilograms is mass. Then this says it accelerates at 9.8 meters per second squared. So we know that's acceleration because the problem tells us that, okay? Also, meters per second squared, that's a unit of acceleration. And finally, it asks us, what is the force of the car when it hits the ground? So we're looking for force. Now we finished our categorization step. We've got all the symbols that we need. So we're gonna choose an equation that has all these symbols. Now, in this video, we're only using one equation for the whole video, so we know this is the one we use. But just to check, we need to have M, A, and F. We've got M, A, and F, so that's the equation. So we're gonna write force equals mass times acceleration. And now we're just gonna plug in our numbers. So force equals 4,000 kilograms times 9.8 meters per second squared. All right, and when we multiply those numbers straight across, we end up getting 39,200. And our units are kilograms times meters per second squared, okay? Now, in this situation, we could leave it like this, but I always want to write newtons if I'm solving for force. All right, so I just want to show you all how to know that, or how do you know when to write newtons. So a newton is equal to, and I'll write this in red, a Newton, which is the unit of force, is equal to a kilogram times a meter per second squared, right? Because that is mass times acceleration. So a kilogram times meter per second squared. So whenever I see kilogram times meters per second squared, like right here, I can actually erase that and just substitute in a Newton. So our force on this car when it hits the ground is 39,200 newtons. All right? Cool. So I'm going to leave that Newton up there because we're going to need that later as we do some more problems. But now we're going to move on to the problem for mass. Okay? So the first one was force. Let's write mass at the top of here in case someone wants to jump around through the video. Okay, so for our problem for mass, the question says a soccer player kicks a soccer ball. The force on the soccer ball is 130 newtons. The acceleration of the soccer player's foot is 9 meters per second squared. What is the mass of the soccer player's foot? All right, so the soccer player kicks the ball, contacts the ball, making 130 newtons of force. The soccer player's foot was accelerating this fast, and we're trying to figure out what is the mass of the soccer player's foot, okay? And again, we're focusing on the soccer player's foot because we didn't tell you the acceleration of the ball. We told you the acceleration of the soccer player's foot, so we can only use that to find the mass of the soccer player's foot. All right, so again, when we read through this problem to categorize it, just read the problem closely and it'll tell you what each measurement is. So it says the force of the kick was 130 newtons, so that's F. Says the acceleration of the soccer player's foot was 9 meters per second squared, and we're looking for the mass of the soccer player's foot. So now we go ahead and just make sure that in our equation we have all these measurements. So we've got FAM. I said that we have all these measurements, all these symbols, all these variables. So FAM, we see over here, F, A, and M, we've got all of them. So we can go ahead and use that equation. So F equals MA. Now we're gonna plug in all of our measurements. Now here's one thing I wanna note. I personally like solving problems algebraically before I plug in numbers. But for the sake of students who may have trouble doing algebra, this video is not necessarily covering how to symbolically solve this problem. We're just gonna solve this problem by plugging in our numbers and then figuring out what to do in the equation. So I'm actually gonna drop this a little bit in case you can't see the bottom of my screen. Hopefully that works. Okay, so what we're gonna do is go ahead and plug this in. Let me actually make this a little shorter so that we've got more room. All right, so we're gonna evaluate. So I have a force, so I'm gonna plug that number in, 130 newtons. Okay, I don't know my mass, that's just gonna stay as M, and my acceleration is 9 meters per second squared. All right, so you see how I just plugged in my numbers in the equation? All right, now we're gonna solve this equation. In order to do that, we want to find M. We wanna know what the mass is. So we have to get the mass by itself. Currently, the mass is being connected to this acceleration by multiplication. When things are written next to each other, there's an invisible multiplication sign there. So in order to separate them, I need to do the opposite of multiplication. I need to remove the 9 meters per second away from the M. And to remove this away from the M, I'm gonna do division. Now, I've had a number of students make the mistake of saying, if we wanna get M by itself, we're gonna actually move M. That's not the case. M is in the right spot. We just wanna move everything else away from M. So we're going to divide by 9 meters per second squared. All right, and that'll allow us to cancel both of these out. See, let me do that whole thing in red. So we're going to divide by 9 meters per second squared. So we can cancel both those out. And whatever I do to one side, I do to the other side. So I'm dividing by 9 meters per second squared over here. All right, so now I have m by itself. Now there are a couple more things we have to do. So first of all, we got to do 130 divided by 9, and that's going to give us 14.4. Okay, now in order to figure out our units, we have to use this trick over here. So we know that newtons is equal to a kilogram times meter per second squared. Okay, so since we know that, now we rewrote it. We wrote a newton as a kilogram times meter per second squared, and we see we've got meters per second squared in the numerator and in the denominator, so we can cancel those out, and we're left with kilograms. Okay, now you can do it that way. We also know that mass is in units of kilograms, so that can help you kind of figure out, oh, this has got to be kilograms for the final unit. But also doing it this way, substituting in the newtons for kilogram times meters per second squared, that'll help you see what cancels out and show you what's left, okay? So I'm gonna go ahead and erase this, all right? We're gonna move on to our last problem, which is gonna be an acceleration problem. Let me go ahead and write that as well. So this problem is acceleration. Okay, so this problem says the force of a wrecking ball hitting a building is 45,788 newtons. The wrecking ball has a mass of 7,829 kilograms. What is the acceleration of the wrecking ball? Cool. All right, so again, identify step, we just wrote down all our measurements, all the numbers they gave us, and we wrote down a question mark so we know what we're looking for. So we just read the problem closely. It tells us 45,788 newtons is the force of the wrecking ball. It tells us 7,829 kilograms is the mass. Again, we're drawing this directly from the problem. Also, we know that newtons is a unit of force, kilograms is a unit of mass, so that helps. And then it asks us, what is the acceleration of the wrecking ball? Okay, so now we've got F, M, and A as our symbols, our variables. So we're gonna look for an equation that has F, M, and A. This equation over here has F, M, and A, so we are good to go. So I'm just gonna write the equation down here so we know that's the one we're using. And now we're gonna go ahead and just plug in our variables. So we have a force, so that's 45,788 newtons. And that's gonna equal mass, which is 7,829 kilograms, times acceleration. Okay, now again, in order to solve this problem, we need to get acceleration by itself. That doesn't mean to move the acceleration, because if we move it, we're moving it to a side with another thing on it. We don't want that. We want it by itself. So we need to move this number and move it away from the A. Okay, now currently multiplication is happening between the A and this number. So we have to do the opposite of multiplication to separate them. So that means we're going to divide. So 7,829 kilograms, and divide. So these are going to cancel out. And whatever we do to one side, we have to do to the other side. 7,829 kilograms. All right. So because these two numbers canceled out, I know I have acceleration by itself on that side of the equation. And now I just have to solve this portion. So 45,788 divided by 7,829 is going to be 5.85. Okay? And now we have to figure out the units. Now again, just like in the last problem, in order to do that, we're going to want to replace the newtons with kilograms times meters per second squared. We're just going to break it up so that we can see if any of those units cancel out. So a newton is a kilogram times a meter per second squared. Kilogram times meter per second squared. Okay, and so now we're just looking to see if anything cancels out, and in fact it does. We see kilograms up top and kilograms on the bottom, so those cancel out. And we're left with meters per second squared. Now again, because we're solving for acceleration, you actually know that the unit is displacement over time squared. So you could have said, oh, I know it's going to be meters per second squared. That's great. But we just wanted to show very explicitly how to calculate that or how to get there. All right, so that's 3 different ways to solve the force equation, Newton's second law. Thanks for joining and have a good one.